Refer to the graph of y equals sine of x to find the exact values of x in the interval from 0 to 4 pi that satisfy the equation sine of x equals -1. Well, we better sketch the graph of sine of x over the interval that we're looking at. If we have our x-axis here and our y-axis here, we're going to graph y equals the sine of x. We know from our knowledge of the unit circle, which I'll also sketch for reference here, that the sine of 0 is 0, because for an angle theta, the xy coordinate of a given point is equal to the cosine of the angle and the sine of the angle. So the y coordinate gives us the sine, and when we're dealing with an angle of 0, the sine of 0 will be 0 because we're looking at the point 1, 0. So the sine of 0 is 0. As we allow our angle to increase, and notice there's a bit of an incongruity here because the x represents the angle that I'm taking the sine of when I do the sine of theta, or sine of the angle. In my notation here, I have to refer to xy as the coordinates of the point, and so x in this case is the x coordinate, not the angle. I hope that doesn't confuse the matter too much. I will let this theta increase, this angle increase, and as that happens I move along the x-axis in the graph that I'm producing. As theta increases, it reaches its maximum at the point 0, 1, which is when theta is pi over 2. So as we trace along our angle axis, we get to pi over 2, and that's the largest value that the sine takes on, and it takes on a value of 1 there. And so I'm going to put a point at 1 pi over 2, and I'll connect the dots in the way that I know the shape of the sine curve behaves. Now, sine will once again be 0 when this angle wraps down to the x-axis again. That will be an angle of pi radians. So I'm going to come down here to pi. Now the curve continues as the angle wraps to to 3 pi over 2. I'm going to have a y-coordinate of -1, that's 0, -1, and I'm going to come all the way down to a -1 on the y-axis. When I get out to 2 pi, which is a full revolution, I'll be back to the point 1, 0, and the sine will be 0 again. Now we're supposed to double up this period. We're supposed to look at the interval from 0 to 4 pi. So I'll leave that to your imagination. This entire curve can be duplicated one more time to go through one more cycle of the sine. But this should give us a chance to answer the question. Now we're looking for all the values of sine that are equal to -1, actually specifically all the values of x that make the sine equal -1. We found one of them already. X equals 3 pi over 2 is one of the values of x that make this true. Another will occur when I repeat this cycle a second time. I will come back down and have a second place where my y-coordinate is -1. On my unit circle, that's going to occur once I've wrapped around not just a 3 pi over 2, but I've gone a full revolution again beyond that. So I'm looking at 3 pi over 2 plus another 2 pi. Now I should simplify that. That's 3 pi over 2 plus 4 pi over 2. That's getting a common denominator for the 2 pi over 1 term here. And that gives me 7 pi over 2. That is still less than 4 pi, right? 8 pi divided by 2 would be 4 pi. So I've got a number that's less than 4 pi, so I'm within the bounds of the interval I was looking for. But if I go another 2 pi, I'll have gone too far. Likewise, if I started here and went backwards another 2 pi, I would be outside of my interval on the low end. So there were only two angles that worked. There was the angle 3 pi over 2 and the angle 7 pi over 2.